Chapter 2. Thank you. I heard before that we loved being quiet for a bit and then suddenly yelling, so decided to go for it. Chapter 2. Here are things you should know. First thing we talked about was percentile. So you should know how to find a percentile and how to interpret one. So you should be able to tell me that in the context of a problem that a percentile is the percent of all values that are below a specific value. Then in that first section, we also talked about z-scores. So if I ask you to get the z-score of a particular value and tell you the mean standard deviation, value minus mean over standard deviation, you should be able to know that. So calculating z-scores. You should be able to read a cumulative relative frequency graph. It's a graph of percentiles. The example we looked at in the notes was the age of the president's at inauguration, and we used it to get the percentiles and to be able to interpret it. So the x-axis was the values, and then the y-axis was the percentile. And so you should be able to, if I give you a graph like that, then you should be able to tell me, okay, here's what this value can tell me. You should be able to tell me where a certain percentile is. You should be able to tell me like percent of values in between these two numbers by like taking the percentiles and subtracting them, and so on. That's most of section 1. Section 2 was about normal distributions. So you should be able to use table or calculator to do work with the normal distributions.
So it's totally acceptable if we use calculator on this test.
Absolutely.
Okay.
Now, I want to see your work.
Okay. Just to make the
I want to see like your so you should have a picture. Remember I said we should draw a picture of everything. So I'm expecting a picture. If you're calculating a z-score, I want to see what numbers you're plugging in for the z-score. But once you get to that point, you can either read off the table or use the calculator. It's a personal preference. Whichever one you have the easiest time using, use it. So I want to see your work on calculations. Remember, on the calculator, normal CDF, you're going to use for if we know the value and want the proportion. So if we're trying to find what proportion of values, if we're trying to find a percentile that a certain value is at, then we want to use normal CDF. We calculate the z-scores and read the z-scores off the table, or put in normal CDF with the lower upper mean standard deviation. Inverse norm, if we know proportion, usually a percentile, and we want the value. That's working backwards to get, okay, this proportion or this percentile matches up with this z-score, and then I can work backwards from there with the z-score formula to solve for the value. If that does not sound familiar to you, it's probably because you weren't at the meeting on Friday and you need to catch up with that. So make sure you get caught up with that before tomorrow. Get the notes from someone else. It should be in. There should be some stuff with how to do it in the book. There's a section on kind of reading the table backwards. You can look at that. So if you missed that on the meeting Friday, make sure you get caught up on it. There's a video in the playlist on how to do stuff on the calculator if you don't remember. So if you need to look back at how do you do that on the calculator again, it's there. Skip anything with normal probability plot. I put an announcement about that out yesterday that you should have gotten. So if a homework question asks you about normal probability plot, then skip it. Or skip that part of the question that has to do with the normal probability plot, because we didn't talk about it. We'll talk about it more when it becomes relevant again. I just didn't get to it right now. What else? For z-scores, you should know that a z-score shows an amount of standard deviations above or below the mean. So you should be able to understand that a z-score tells me how far above or below the mean we are. It gives me it's sometimes called a standardized score because it gives us a baseline to talk about all distributions in the same way, to give a more direct comparison between them. Last thing, transforming data. If I add, subtract, multiply, divide all the numbers, what will that do to the mean and standard deviation? And you should be able to explain why. So if I take all the numbers and add 5 to them, you should be able to tell me what's that going to do to the mean, and you should be able to tell me what's that going to do to the standard deviation and be able to explain why. That was something else we talked about. There we go. That's a bit better. And this will not come up big on the test, but another type of distribution that I might have mentioned before is a uniform distribution. So that's what 17 is about when we were asking about 17. A uniform distribution, uniform, synonym for uniform is staying the same throughout. Right? If we had school uniforms, it would mean that everyone is wearing the same thing. So a uniform distribution would be that the distribution looks the same everywhere. Versus like a normal distribution has like a peak at the center. Uniform doesn't have that. And so if we're looking at talking about going within one, then you just want to shade the area, and you just want to shade the area that is. So what values are we interested in going between? This is just a hint to get you started. What values are we interested in going between? And then using that to figure out what the area is going to be. And so is the area underneath all of this, any curve like this, the area underneath all of it should be 1. Same for the normal distribution. The area underneath everything in the normal distribution is going to be 1. So if the area under this is 1, then you know what the width is. It goes from -1 to 4, so the width is 5. So you should be able to figure out what the height is. And then the smaller box that we're interested in, you should be able to tell me what the area of that box is going to be. So that's how we do that problem. Don't worry about it too much for the test. But that should be a hint to get you started on it. All right, let's go back to talk about the multiple choice. Number 1, are we skewed? No. Is that a normal curve? Does that look like our usual normal curve we've been drawing? No, it doesn't. Well, the main thing that's missing is that the normal curve would have these tails on either side. Right? The normal distribution, which you should be able to draw pretty cleanly from now, looks like this. It's got these tails on either side. And it kind of starts to swoop up like this and then have the tails that keep going. This one doesn't have that. This doesn't have the tails that keep going and curve back up. So this shape is symmetric. So if we have a symmetric curve, how do the mean and median compare? They should be the same. Mean should be the same as the median. In a skewed distribution, the mean gets pulled with the skewness. But since we're symmetric, the mean and the median are equal. That's true in a normal distribution as well, since a normal distribution is symmetric. The mean is where the median is. Number 3. Oh, one more thing I forgot. And this is what this one uses. Where is it? 68, 95, 99.7 rule. We can use this to do some of these problems quickly, because that tells me 68% of the data is within 1 standard deviation, 95% of the data is within 2 standard deviations. So if we're looking at this problem, you'll notice that between 16.0 and 16.1, if you draw the picture of that, then you'll notice that it's at the mean, and then we're going 1 standard deviation to the left. So you should be able to use that 68, 95, 99.7 to give standard deviations to the left. And since it's only the standard deviation to the left, then it's not going to be 68, because that's on either side. It's just going to be on one side, so we cut that in half, 34. On number 4, less than 16. Again, draw a picture, shade it, get your answer there. 5 we skipped. 6. Area under a normal curve is always 1, regardless of the mean and standard deviation. Well, the area under any density curve, any type of curve like this, is always going to be 1. So that's true. We just said a normal distribution was symmetric, and so the mean and the median should be the same. Interquartile range. So mu plus sigma and mu minus sigma. What was mu again? What did we use for mu to stand for? It's the mean, and then sigma is standard deviation. So this is saying going a standard deviation to the left and a standard deviation to the right. Standard deviation to the left and standard deviation to the right. Zero, -1, and 1. So here's a standard deviation to the left and a standard deviation to the right. So this middle area, what percent did we say was within 1 standard deviation? It's 68. This is 0.68. 68% of the data is within 1 standard deviation. What percent of the data is the interquartile range? So interquartile range, remember, is Q3 minus Q1. So the percentile Q3 is 75th, right? And then Q1 is the 25th. So if we have the 75th percentile minus the 25th percentile, that's going to be the middle 50%. Is this number 50%? No, it's not. So 3 is not true. My hint for you, number 7 is 1.25 is in a standard normal distribution. That means we're looking at z-scores. So if our z-score is 1.25, then we're asking what percent is greater than the z-score of 1.25. So that you should just be able to get to the table in the calculator and get out your answer. Here's a cumulative relative frequency graph. And so it asks what proportion in the race finished more than 2.15 hours. So 2.15 is right here. So what percentile is that? Around? Well, we have 0.2, 0.4. Around the 55th percentile, I would say. Because here's the 50th percentile. So we're around the 55th. But what does the percentile tell me? It tells me how many of the values are under the 2.15. Right? That's what a percentile is. But the question is asking what percent is more. So 55% is below, what percent is going to be above? The rest of it, right? So 45%. This 10 is also a normal distribution calculation. I'll tell you that you should get B on number 10. On number 9, distribution is skewed right. This is a question that's really asking 2.164. So what I'm really doing here, I won't do the whole thing, but the z-score, to get the z-score, we're going to take value minus the mean over the standard deviation. That's our formula for z-score. So our formula here is value minus the mean over the standard deviation. And so basically this is asking about what I called the transformations earlier. I'm saying I'm taking all the values, all the list of the values, and I'm subtracting 2.164 from all of them. Take all the values and subtract the 2.164. What's that going to do to the mean, and what's that going to do to the standard deviation? Then after that in my formula, I'm going to divide all the numbers by 0.85. And so what is dividing everything by 0.85 going to do to the mean and standard deviation? That should get you started in figuring out. And again, you should be able to explain why it does those things to the mean and standard deviation. So that is the multiple choice on the review.